Hi guys, this is Easy Elimu. I'm Vincent Kanumwai. I'll be your teacher for today. I'm going to take you through linear programming, and the first thing we are going to start with is forming linear inequalities. Stay tuned as I welcome you all. Inequalities of any given situations in life. This forming of inequalities, let's say this is chapter 7. So meaning this 7.1. So forming linear inequalities here, we are going to deal with those inequalities that deal with real life situations. We are going to handle some of the given inequalities with the given condition that involves our lively basic, which we deal with today, tomorrow, and any kind of what we involve with in life. So we may start with our first example. Here we are only dealing with forming linear inequalities, not solving. So we will deal with our first example, and in our first example we have been told that the perimeter of a rectangle whose length is x centimeter and width y centimeter is not more than 10 centimeter. The first thing you should understand in linear inequalities is only one. You should always understand the question before writing anything down or before analyzing anything. You understand the question first. For instance, if we have been told the perimeter of a rectangle whose length is x centimeter and width y centimeter is not more than 10 centimeter, you should first understand what are the dimensions which they are talking about. You should be conversant with the rectangle and its side. For instance, we have been told this is our rectangle. The length is y centimeter and width is x centimeter. But we have been told that the perimeter of a rectangle whose length is x centimeter or length is x centimeter and width is y centimeter. So meaning that the perimeter is not more than 10. Meaning that the perimeter is either 10 centimeters or less than 10. So meaning if we find the perimeter and we know the perimeter of a given figure is the distance around all that given figure. So here we know the perimeter here to obtain is 2 into length plus width. But here our length is x plus y, which is our width. So we are finding it will be 2x plus 2y. But we have been told is not more than 10 centimeters. So meaning this one will be less than or equal to 10. That is what we are being informed. If you factor out 2, you will find that x plus y is less than or equal to 10. Actually, if you factor out 2, it divides both of them into 1, 1, and then 10 divided by 2, you are getting 5, not 10. It should give you 5. So we shall find that x plus y is less than 5. Now let's see the equation. Find all the inequalities connecting x and y. So we have been told that the perimeter of a given rectangle is not more than 10, meaning it is either 10 or less than 10. That's why we are saying that if we take 2 into x plus y, we should get 10 or less. So remember one thing. Length is a positive measurement. We cannot have a negative measurement. So that means that x is greater than 0. And at the same time, y, which is width, it has some measurement, which means it cannot be negative. So meaning it is also greater than 0. And these are the required linear inequalities that we were required to form. What do I mean? I mean, before answering any question, understand first what they are talking about and relate it to real life situation, what you know. And you will find what you are supposed to do. Let's see another example whereby we have been told a factory produces at most 400 items in a day. The non-defective items sell at 100 shillings each, while the defective ones are sold at a discount of 40%, giving a day sale of at least 30,000. If a day X non-defective and Y defective items are solved. Form the inequalities to represent the situation. So here we have been told the X is the non-defective solved, non-defective item solved, and Y is the defective item solved. These are the defective items solved. So, to form the inequalities required, the first thing we have to understand the equation. They are saying a factory produces at most 400 items. At most 400 items. And if X are the non-defective items and Y defective items, then it means if we add the two items, that is the non-defective, all the non-defective items, we add to defective items, we should get, we are told at most. At most means what they produce mostly is 400, but at sometimes they do produce less than that 400. At most means it is either that what you have been told or less than that. But if it is at least, it means the minimum production is what you have been told. But at most is the maximum production being given out. So it means it is either X plus Y at most means it is what? At most we have said the maximum production is that one. So that one will be greater than or equal to 400. It should be this X plus Y at most 400. So meaning it is either 400 or less, not should be more. It is 400 or less, meaning at most the maximum production should be 400. So we find that the non-defective items sold at 100 each, while the defective ones are sold at a 40% discount. So if we take a 40% discount, we are finding it will be 60%. You take 60 over 100 multiplied by 100 shillings per defective, and you find is 60. So the non-defective items, which are Y, are sold at 60 shillings. So these ones are sold at 60 shillings, and this one are sold at 100 shillings each. So we shall find that if they are sold at that price, giving a day at least 30,000, the minimum amount sold is 30,000. So we shall say 100 shillings per each of the non-defective item. We multiply the number of defective items, then we add to the number of defective items, multiply by the price sold per each defective item. We should get at least the minimum amount is 30,000. That is what they mean. So if we do simplify here, we are going to get, let me think of the little one. If it is equal to 1500. Really? Yeah. So this one is amounting to that. And then we have been told, form all inequalities to represent the situation. So we have found out that X plus Y should be less than or equal to 400, and also on simplification 5x plus 3y is greater than 1500. So it's greater than 1500. And then remember one thing, these are items, they cannot be negative, meaning they are always in counting of numbers. So it will be either 1, 2, or 3, or up to other points. So meaning that x is greater than 0, meaning that they are not negative, and also y is greater than 0 because it's not negative. So these are the 4 inequalities we were required to form using that equation. We shall see how we can find the solution of a linear inequality given the problem and a condition in our next session. We are going to handle another section in linear programming, which is dealing with the solution of linear inequalities. And here we are being told that we can solve each problem with a given condition separately, and then we come to reunite them, finding the final result. For instance, we shall see that using our examples. And for here we have one of the examples we have been told Mary is twice as old as Jane, who is her sister, and Jane is not less than 5 years old. The sum of their ages is not more than 30 years. Given that Jane is X years old, form the inequalities in X to represent the above information and then find the range of values of X satisfying the inequalities. What we should first do here is, we have been told that Jane is X years old, but she is not less than 5 years old. So meaning X is greater than 5 years old. She is not less than 5. She is not less than 5. What does it mean? She is more than 5 years old. So we have also been told that if we take Jane, Mary is twice as old as her, so meaning that Mary will be 2. If Jane is X years, then Mary is going to be twice as old as Jane. So Mary will be 2. If the age of Jane is X years, then that of Mary will be 2 multiplied by X, which is twice, is 2X. But we have been told that the sum of their ages is not more than 30 years. Is not more than 30 years. That if we take 2x plus x is not more than, meaning is less, is not more than 30 years. So it will be less than 30 years. On calculation, we are going to get 3x is less than or equal to 30. So over 3, we are going to get x is less than or equal to, here we are going to get 10. It's giving us 10. So we shall find out that x is less than or equal to 10, but x here is greater than 5. So we have solved the two inequalities differently, and we now need to reunite them to find the range of values that is satisfying the inequalities. But here we have said, firstly, x is greater than 5, and at the same time we said x is less than 10, is less than or equal to. So what we should do, we should start with the least, which is 5, but this 5 is less than x, and this x is less than or equal to 10. And this is the range of inequalities we are requiring to give. So we can finally give the answer as 5 is less than x, which is less than 10. And this one are a number of years. So we have found that the number of the age of Jane is either 10 years or less, but is not less than 5. So meaning is more than 5 years. And we are saying that the length of a room is 4 meters more than its width, the width is greater than 5 meter, while the perimeter of the room is not greater than 36 meter. Given that the width of the room is b meter, find the range of values of b satisfying all the inequalities representing the given situation. So if the length of the room is 4 meters more than its width, and the width is greater than 5 meters, and we are also being told that the width of the room is b meters. So if it is b meters, we can say that b meters, that's the width of the room, but we have been told that this width is greater than 5 meters. So meaning that b is greater than 5 meter. So if b is greater than 5 meter and b is the width, we can finally say that the length of the room is 4 meter more than its width. So if b is the width, then the length is equivalent to b plus 4. We can solve that way. And then we have been told that the perimeter of the room is not greater than 36 meter. So we know this is a rectangle, and if it's a rectangle, 2 into L plus width is not greater than 36 meter, meaning 36 meters or less. So if it's not greater than 36 meter, what we shall do is we substitute here L and also width. So we are getting 2 into L, which is b plus 4, plus L, which is b, plus width, which is b. It should be less than 36. So if we open here, we are having 2b. 2b multiplied by 2, we are getting 4b, plus 8 is less than or equal to 36. So divide it, bring it the other way. We are finding that if you take 6, you subtract 8 is going something like 28. So if we have 4b is less than or equal to 28, then what we are obtaining here is that b is less than or equal to 7. But here we were told b is greater than 5, because we were told the width of that rectangle is more than 5 meters, but the perimeter of it is not greater than 36 meters. So we are finding that b is less than or equal to 7. At the same time, b is greater than 5. So meaning we can take 5 is less than or equal to is less than b, but this b is less than or equal to 7. So that is the range of values which was satisfying the given inequality. This was 5 meter, 7 meter, because b is in dimension of meters. We have seen how we can solve the solution of linear inequalities separately, and then we bring the solutions together to form one required and expected result, as we have been doing. You can use the same approach. You understand the question very well, and then you solve it. At the end, you give the result at your own homework. Thank you. We are going to see how we can solve the linear inequalities using graphical methods, and this is whereby we draw it on graphs, and then we identify points which are suitable and may be possible situational solutions to the problems or conditions we have been provided for. For example, we may have a problem like a student wishes to purchase not less than 10 items comprising books and pens only. A book costs 20 shillings and a pen costs 10 shillings. If the student has only 220 shillings to spend, form all possible inequalities from the given condition and graphs, and clearly and form a graph and then indicate the possible solutions. What we need to do here, we need to analyze first the question as we said earlier. After analyzing the question, we understand what the problem seeks, and then we do as we are directed. For instance, here we have been told the student is wishing to buy only items which are not less than 10. And these items comprises books and pens. So we may say, let the number of pens bought by the student be, let the number of pens be equal to X. The total number of pens bought by the student be X, and also we let the total number of books, let the number of books be equal to Y. If that is the case, we know that if we have been told that a student wishes to purchase not less than 10 items comprising books and pens only. So this indicates that if we take the total number of pens which were purchased by the student, we add to those of books which were purchased by the student, we should get something which is not less than 10. So meaning the sum of the two is not less than 10. That sign is wrong, meaning it's less than 10, so it should be greater than 10. The sum of the two should not be less than 10. So from there we have been told a book costs 20 shillings and a pen costs 10 shillings. If a book costs, we have a book costing 10 shillings, meaning the total amount spent on books will be 10Y. And if a pen costs 10 shillings, it means the total number of, or the total amount spent on the pens will be 10x. A book is 20 and a pen is 10. So we have been told the student is having only 220 shillings to spend. So meaning what? If we take the total amount spent on books, we add to the total amount spent on pens, we should get either the total amount the student is having which we have been told is 220 shillings. It should be either that 220 shillings or less than 220. So that is the inequality. The first one we formed is here. So doing that, we can simplify this one further, and we find 2y plus x is less than or equal to 220. And here we had x y. The next inequality was x plus y is greater than or equal to 10. But we know from the description, we can comfortably say that if you go to purchase an item, it means you will at least purchase an item. So meaning the number of books purchased will be greater than 0, meaning you will at least purchase something. The same applies to the number of books purchased if this is the number of pens. So we have 4 kinds of inequalities. One is the first one, the second, and the third and fourth. We now need to graph them and find the possible solution that we may attach according to it. After understanding the question, forming the inequalities that are required, then you now use the graph to identify which parts have been asked. Let the y-axis represent the number of books bought, number of books, and the x-axis represent number of pens, which means this will be x and this is y. So on doing that, we can plot x greater than 0, meaning that all the values that we should get should be, this is where the both lies. So meaning that the value, if x is greater than 0, this implies that the values which we will get should not exceed the negative values of 0. So meaning you should go from 0 to positive values, not the negative ones. So meaning the other side will be shaded. But because this one which we have here is greater than and is not greater than or equal to, then this our line will change. The line changes to dotted line simply because it is greater but not equal to. So meaning the values which will be found on this line are not considered because they are not within the range which we need. So we shall shade the other part because we only need the positive parts which are beyond x greater than 0. The same applies to y greater than 0, meaning that all the values which are beyond y, which is negative, we don't require them. We consider only values which are positive. So if that is the case, the same applies to this. So that is the case. So if is that the case, then it means we shall shade the downward part. And this one we have found, this line is what we are having, y greater than 0, and this is x greater than 0. So having that one, we can now put this one we are finished. So we need now to plot this one. And on plotting this one, we can even make an assumption of this, because the line which will form will be now continuous line, not dotted, because it is greater or equal, meaning the line, the points which will be on the line are also the possible solution which we seek. So if we do that way, we shall find that the value of x, if x is 0, we can find y to be 10. Let's just take in big denotions, that is like x. If x is 5, we shall find y to be 5. And if x here, if x is 10, for example, y will be 0. And if x is 15, y will be -5, and so on. So if that is the case, so we can plot this one is 0, 10. So we have, if this one is 0, then this one will be passing through this point. If the number of pens are 5, then that of books should be also be 5. So x 5, so we are finding it to be a middle somewhere there. And then 10, 0. If this one is 10, then it will be here, 0. And so on. If we had plotted there downward, you will find it will be somewhere here. So meaning we have a straight line. It's a straight line passing through those points. And then we have been told x plus y should be greater than 10. I have put a continuous line because it is greater than or equal to. Meaning also the points that will be located on these lines are also required. So if we do that way, we are going to have, if x plus y is greater than 10, then it means the values or points which are below the line are unrequired. What we want the points which are beyond this line. So if that's the case, then we are going to shade the downward part. How do you identify? You take any point, for example 5 here, you take, for example 5 5 and 4 here, a point which is at the downward part. If you take 5 and 4, if you put here 5 and then here 4, you will find it is 9, and 9 is not greater than 10, so we need to shed the downward part because it's only the upward part working. Then for the other case, we need to find also this. I think here is okay, we can wrap. We can take that of x and y too. If x is 0, not to 20, it should be 22, because if you simplify it will give you 22. Then if x is 0, y as 11. If x is 5, we shall find y as what? 5, that is 17. Let me use this one to correct it well. So forming the inequalities this way, we can find this by graphing that. So after finding the values respectively like that, we can say if x is 0, we find y is 11, and if x is 5, y is going to be 8.5, and if x is 10, y will be 6, so somewhere up here, 6. And if x is 15, we are going to have y as 3.5, somewhere here. So we find that this is 8.5, somewhere here. So we shall find it is a line passing through this point and cuts the x-axis at that point. So we are going to have that line, and the first line gave us x plus y, but since we say greater than or equal to 10, so meaning the line will be x plus y is equal to 10. This one now will be 2y plus x is less than or equal to 22. So because the line is joined, so it will be equal to, because also the points that will be located on that line are also considered. So after doing that, we have seen how you can find that. So we need to shed the part which is unwanted, which is not required. What we will do, we shall select one of the points. For example, we shall take x as, let's take x and n of the above like 10, which point like here, a point above here. And we say this is x15 and y, or let's just even take a simpler point, x be 10 and y also be 10, so we find it at point here, 10. So a point here. We need to identify that point. We shall substitute here where y is 10 and x is 10. So if we substitute, we find 2 by 10, 20, 20 plus 20, you are getting 20 plus 10, you are getting 30, but 30 is not less than or equal to 22. This one is not true. So meaning the outward side is not true, so we need to share the outward side. But remember, we shared the downward, we shared the other side, we have shared this side, we have shared, so we have remained with only the one which is in the shaded region. This region is what we require now. So according to this solution, this problem we have here, any of the point that lies in the middle of the unshaded region satisfies our equation which we require here. Any of the point, for example, for instance, you can take 10 and 5, like a point like that. So if you take 10 and 5, if x equals to 10, you will find, even if you put here x be 10, and y be 5. So you will find this one is automatically greater than 10. And if you take that we have said is x and 5, so 10 and 5, so if you put here 5 and here 10, you will find 2 by 5 is 10, 10 plus 10 is 20, 20 is less than 22, meaning that point is satisfied. So any of the point which lies within the region or the unshaded region satisfies our condition. What do that mean? That means that we have come to a conclusion that in graphical method, we only need to form the inequalities that are required, and then after forming those inequalities, we draw them on a graph by identifying the joining and the joint, and also identifying the parts which are required. So the points which are required are based in the unshaded region after drawing the graph.
We have already learned how we can form linear inequalities in case we are being given some problems including linear inequalities, and how we can graph them on a Cartesian plane or given a graph. Now we are going to see how we can solve given problems and select one or more best solution that can fit that problem using a graph. With that, we shall use an example which will direct us or help us to do the work better. Let's see how we may do it. We have an example here, and one is a contractor intends to transport 1,000 bags of cement using a lorry and a pickup. The lorry can carry a maximum of 80 bags, while the pickup can carry a maximum of 20 bags per trip. The pickup has to make more than twice the number of trips the lorry makes, and the total number of trips must be less than 30. Now, the cost per trip is 2,000 per the lorry and 900 for the pickup. Find the minimum expenditure. Now, we need first here to use the technique that we have been using in the previous session and form the linear inequalities of the respective problem we have been given here. For example, here we are not given the number of trips per each vehicle, that is per lorry and also per the pickup. So we shall say let the number of trips of lorry be equal to x, and that of the pickup be equal to y. After sorting that, we have been also informed in the question that the pickup has to make twice as more trips as that of the lorry. So meaning that if the pickup has to make twice as more trips that of the lorry, then we can form some of the inequalities here. Inequalities. And we can form the first one. We shall say y is greater than, actually we have been told the pickup has to make twice as more trips of the lorry. So it shall be, if the lorry is x, then the pickup has to make twice as more. So meaning that y is greater than 2x. From the question again, we have been told that the total number of trips has to be less than 30. Has to be less than 30. It means it is either 29 and below. So if that is the case, it means that if we take the total number of trips that the lorry makes, we add to that total number of trips that the pickups make, then we must get less than 30 trips. From the same thing, we have been told that a contractor intends to transport 1,000 bags of cement using lorry and pickup. And each lorry carries a maximum of 80 bags and a pickup carries a maximum of 20 bags. So meaning that if we take the maximum number of bags carried by a lorry, we multiply by the number of trips, we shall get the maximum number of bags that a lorry carries in X trips. For example, if we take X multiplied by 80 bags per trip, then we are going to get 80X. And this is the total number of bags that a lorry will carry in X trips. So meaning that if we take that 8X plus, now that of the pickups, we have been told or informed that it carries a maximum of 20 bags per trip. And we have Y number of trips. So meaning that if we take Y, we multiply by 20, we are going to get 20Y, meaning that if there is 20 bags per trip, that is the maximum number of bags a pickup can carry. We multiply the total number of trips that pickup makes, then we shall find the total number of bags that were carried by a pickup are 20Y. So if we add, we have been told that it should be greater than or equal to 1,000 because he is intending to transport 1,000 bags. And if he is intending to transport 1,000 bags, it means he may transport that 1,000 or even more than that 1,000, but he's not intending to transport less than that 1,000. So that is our inequality. And if you simplify this inequality here, you will find out that you will have, you can divide both sides by 20 to simplify it more further. You will have 4x plus y is greater than or equal to 50. So we have found that inequality. And at the same time, we have been told that the cost per trip is 2,000 shillings per that of the lorry and 900 shillings for that of the pickup. So meaning that if we form that inequality for the expenditure, you will find out that you will have, if one trip of a lorry is being spent at 2,000, then it means the total amount or the total expenditure per the lorry will be 2,000 per trip multiplied by the total number of trips that the lorry makes, and it will be now 2,000 multiplied by x, you shall get 2,000x. And that is the total amount that contractor will spend on a lorry transporting the total amount of x bags, x trips. So we shall add to that of the pickup to get the total amount of expenditure. And if we add, we shall now take the y number of trips that a pickup will make multiplied by the cost per trip that a pickup costs. For example, here we shall now take it is 900 multiplied by y. So this is what we refer to as the maximum, or actually it's the maximum expenditure function. And in mathematics, we refer to this one as the objective function because it is the one which will lead us to find which one will be the maximum expenditure that the contractor will make and also the minimum expenditure the contractor will make. From this, we can detect. So let's solve our problem here. Having formed the inequalities, we can now solve. And we can transfer that one as y is greater than 2x. If I may just write it here, x plus y is less than 30. And also 4x plus y is greater than or equal to 50. And we have another objective function. And we have found an objective function here. We have 2000x plus 900y. So we shall see how we may use it to find the maximum or minimum expenditure that the contractor will make. For that instance, we now need to graph this. We have formed the inequalities. Now we need to graph them on a Cartesian plane. Let's start with that of y equals to x. Y is greater than 2x. So if we do that, we can draw a table here and say this is x and this is for y. Line y equals to 2x. Actually, let me use that one because that is the simplest way. So we shall find if this one is 0, we shall have 10. If it is 5, for instance, if it is 0, here will be 0 actually, here will be 10. If it is 10, now I will plot that of y is greater than 2x first, and plot the line y equals to 2x, and we shall see, because this one is greater than, it means the line will be dotted because it is not greater than or equal to. If it could be y is greater than or equal to 2x, then the line could be continuous. But because now we have y is greater than 2x, means whatever I shall draw, the line will be dotted. So that is how we do differentiate the inequalities. Now let's use that technique to draw that one. And if I will plot on the Cartesian plane. If I join on the dots now, we shall find that it's a straight line passing through the origin. And remember we said we are drawing a line of y greater than 2x. So meaning that the line should be dotted, not continuous. So I will make my line dotted 2x. So to identify which side is y is greater than 2x, you select any two kind of points, and you may select, for example, here I may decide to select a point which is on this side at that point here, and I may say this one is 15, 5. So if I take 15, 5, I will see that y is greater than 2x, but 2 multiplied by 15, 15 is my x, and y here I will replace it with the 5 which is there, and I will find 5 is greater than 30. So if you view this statement, it's not quite true. So meaning that is the unwanted region. If it is the unwanted region, I will shade the point, the side or the region where I took the point 5 and 15. So meaning that this is my unwanted region. So that is the region which I will shade. So meaning my linear inequality which I will form, they will not lie within that given region. Then let me plot another linear inequality which we had. This one we have finished. That is x plus y is less than 30. Now this graph here is of the line y equals to 30 minus x. But remember, it's the same as that of x plus y is equal to 30. But here we want to draw that line of x plus y is less than 30. So we shall draw and then we shall identify this inequality. But to draw this inequality or identify it, we need to draw this line of y of x plus y is equal to 30 first. So on drawing, let's put it on a Cartesian plane. If it 0, this will be 30 here. Actually, I can just do that. So on plotting, we shall draw a line like that, and remember that line will be dotted because this one is less than. So I'm going to make my line dotted. So it will be a dotted line as that. So if that is the case, I need to identify this linear inequality here. And if I will identify it, I will select one point which is on one side of that linear inequality. In that, I can take a point like, let's say, let's take 5, 5, a point here. Let's just take a point which is at that point. And if we take that point 5, 5, which is present here, we shall see that if you take x plus y, we should get less than 30. But here we have selected 5 and 5. So we are going to get this one is less than 30. Actually, it's true. And if we take another point, for example, let's say take 5 and 35, a point here. So we shall find out that if you take that point, we are going to have 5 and 35 will give us 5 plus 35 is less than 30. If you witness here, you are going to get 40 is less than 30, and that is not true. So meaning that side we are going to shed the side which is unwanted. The side which we took the point, we shall shed that side. For instance, we are going to shed the upward side, and that will be our inequality. X plus y is less than 30. So we are going now to draw another inequality. This is 4x plus y. We shall draw 4x plus y is greater than 50. So I'm going to draw that line here, but I'll draw that of y is greater than or equal to 50. Actually, I'm going to draw a line of y is equal to 50 minus 4x. So I'll form a graph of that. Then we shall plot the points on the Cartesian plane. Now I've drawn a line of this line of 4x plus y equals to 50. So I've drawn a line of y is equal to 50 minus 4x. And I need to find an inequality of 4x plus y is greater than or equal to 50. So after drawing the line, I will now be required, if it is on a Cartesian plane variable, you will find the points and the line cuts exactly the way you want. So, having drawn it to scale, you will find out that 4x plus y greater than 50, you will select one of the points in either case. For example, I may select as obvious. Me, I will take 510. For example, taking 510, I'll take it at that point. 510 is at this point actually. So taking at that point 510, I will find if this one is 5, this is 10. So 4 multiplied by 4 by 5, I will get 20. 20 plus 10, I'm going to get 30. That is not greater than 50. That is not greater than or equal to 50. So automatically means that the side which I took the points 5 and 10 are unwanted sides. So I will have to shade the side which I took the points. So I will remain with the only one region here which is unshaded, R, which is within the inequalities which I formed. For example, now I'm going to find R lies between that region. R lies within that region. And the line, as you can see well, the line of 4x plus y greater than or equal to 50, that line, now, actually I should say this is the line, and this is also the line. This is also the line. That is the line. That is what I will write that way because that is the line which I drew. But the inequalities formed are actually as given, and we find that the region which we want that satisfies our inequality is within the region which is labeled R. And as you can witness very well, you will find out that there are numerous points in R. For example, you may check different kinds of the points, and if you may check very well, you will find like this point here, the minimum point which may be located at this point. If you check well, you will find it is at that point which is approximate to 8, and to the other side, if this is 15, 16, it may be 17 or 18. Let's say like is 18, the least point we have. So we may find it is 8 and 18. We may find another point like 8 and something else. So it depends with the point you will find from your Cartesian plane after drawing the inequality. Draw it and you see what kind of points we will find. So meaning that if we want to give the solution of that point, which is the maximum expenditure or minimum expenditure, we shall use this. Actually, we shall use this objective function. And if we use objective function, this is the only function that will help us to maximize or minimize what we want to find there. And if you use this one, it means this side we said is for y. So meaning this is number of trips of lorry. This number of trips of pickups, I mean. And this one here is number of trips of lorry. So the trips made by the lorry will be represented by x, and that of the pickups will be represented by y. So this one will be that of the pickups and that one that of the lorry. So if you find something in form of like 8, 18, that means this represents the number of trips of the lorry, and this one is for the pickups. And if you want to calculate the maximum or the minimum amount that the contractor will use to or will spend, you shall substitute where x is and y is, you substitute. For example, you shall select some points from this region and you may select several of them. For example, if I may select, I will find several of them. What you will find out is what we refer to as possible outcome. And if you find out, you will find that you may have numerous points like we have said, that one will be part of them. Let's just see. If you have drawn the graph very well, you will find a point like 8, 18 will be present. You will find out this point also will be present. If you go up, you will find out that you will come to a conclusion that you will find another point which is at that point 8, 22. And also 7, 22 actually, and you will find other points such as, let me just give highlights of the points which you may find from that region. Now from the region R, you shall find out that you might find out numerous points which satisfy the region, which are within the region, such that you will find out some of them are like what I've given out here, 8, 18, up to 9, 20. And if you want to find the price, you can use this function and find out the price. For example, we may find the first one, which is 2,000 multiplied by. Now, that of the lorry, actually, we have first 8, which is, I will replace with the 8. Then we add to 900, which was the price per pickup. Then I multiply by 18. And let's see what we shall find out at the end. Now, using the possible outcomes, which we have here, the digits here, which are located from the region R, you will find out, on working with them, you will have found out numerous of the values which may satisfy the region. E.g., we may find out that these ones are the maximum or possible expenditure that a contractor will use in transporting the bags using lorry and the pickup. But from there, we can find out that the minimum of them is 32,200 shillings, and the maximum that contractor can use is 36,000. And you can also give out clearly that using this method is quite tedious, and you will get tired while calculating. To avoid that tediousness, you will use the objective function to find out whatever we want. I will guide you through. How do we form an objective function? You do this. You will come to this graph here. We want to form a line which will help us to identify the minimum or maximum point from the region which satisfies the linear inequalities we formed. So you will select like point, let's say 5, 10, which is at this point here. Actually, we select a point which is outside the region which we need to maximize or minimize. So if you select that one, then we are going to use that which we had 2000x plus 900y. So we shall say let this one be equivalent to a certain constant, and say if we use this one, we are going to get the expenditure that contractor will use. But we don't know how much will it be. So we are going to select a point like 510. And if we select 510, we shall say 2000 multiplied by 5 plus 900 multiplied by 10. Then we add, we are going to get something like 19. Actually, it will be, that is 10,000 plus 900, we are going to get 9,000 plus 10,000, 19,000. So we are going to get 19,000. And if you get that one, then let's use that one as our function. So we shall say 2000x plus 900y is equal to 19,000. So having that one, we can form still our function here by dividing 900 by 900, actually by 100, not 9. By 100 to make it simpler. So we shall have 20x plus 9y is equal to, we are going to find 190. So we shall form an inequality in that we have 20x. Since this line is outside the region, so we shall say is 20x plus 9y is equal to 190. So we shall use this line which we shall form from that linear inequality, and that line will help us to find the minimum value or the maximum value that the contractor will spend. Let's draw that one on a Cartesian plane. Now from the graph, we can now construct a graph. Actually, we shall construct a line, and I've drawn a line of 20x plus 9y equals to 190 from the points which I selected using the objective function line. So the line which I have drawn here, which is now this one resembling what is here, is what we refer to as search line. That line is what you will use to find out the minimum value or maximum. This is the search line. Is what you will use with it being the reference. You will use that line to find the minimum value of expenditure the contractor will use or the maximum value. Let me help you or guide you how you may use it. Using a ruler and aid of the set square, this is what we refer to as set square. So you will need a geometrical set. Now you will require a set square of 60 degrees, 30 degrees like this, but normally they are 90, or that of 45 degrees like this. You may select one of them. So if you have one of it, you will use your ruler, place the ruler on the search line, this way. This is my search line. Now you place the ruler that way, on that search line, such that it is in that direction. So it is parallel to that search line that way. Then using your set square, either this or the other way, this one. So using one of them, slide it along that ruler this direction as you move closer to the region which you require to maximize or minimize. So you slide until you find the minimum point or the point which is closer to the ruler of that search line that is feasible. For example, for this point, you will find out that the point which is closer, it has the bottom here. which is the bottom, which is much more closer to the search line. So that point is here. And on the graph, if you select that point which we find is that direction, you will find out that that point will give you the minimum expenditure a contractor will use. For the case we have found, that point is at this point here. So if you find out, you will get it is at 0.8 on the x-axis, and on the y you will find out it is giving you 18. If you draw to a graph, that is how you do it. And if you find you use it, you replace in that direction, whereby this now you will remove and use the initial one, which was 2000x plus 900y. So this was the objective function. So after finding the point which was close to your search line, that was much well visible, so you will take those points which will be in form of x and y in form of a coordinate. Now you replace where x is and y is. You will find that point will give you the minimum expenditure that contractor will use. In other terms, if you want the maximum value, you will continue sliding until you find the farthest point to your search line. So if that is my search line, that direction, and I'm using this one as my set square, 8 of them, then we found out that the minimum point which was close or visible to the search line was at this point. But as you continue, you will find that the farthest point from this search line, you will find out it is at that point where, along this point here, you will find out it is along that point. And if you find out that one, if you identify the coordinates of that point, you will find out that it is giving you the maximum amount you can ever have at that point. And that point will give you at this point, so it's going to give you 9 and 20. It will give you 9 and 20. The reason why we are getting 9 and not taking the point which is on the lines is that the lines are dotted, meaning that any point which is on that line is not regarded as one of which will solve our inequality because it is dotted. And if it was like continuous this way, then we could take a point which was on that line because it is inclusive, whereby we are told it is either greater than or equal or less than or equal. But if we are just given greater than or less than, then it means that point is not inclusive. So if you use a set square, I think you now understand how you can use a set square and a ruler to find the most close feasible point to your search line after selecting a point at any point on your Cartesian plane. Then you will use that one to find the maximum value and the minimum value of amount that contractor can use. You can use that approach to solve any linear inequality or any problem pertaining in linear inequalities, and you need to maximize or minimize. So with that, we can come to conclusion of that optimization and say that the process of finding a maximum value or a minimum value is what we do refer to as optimization. And the whole process of what we have just done here is what we refer to linear programming. For instance, we can say we have encountered forming of inequalities. We formed inequalities. After forming inequalities, we have graphed them graphing, so that is graphing of them. So after graphing the inequalities on a Cartesian plane, we found an objective function. You form an objective function, and this objective function will help you to find the search line, as I show you. You equivalent to any point, and then you select a point which is not in the area which you require or a region which is satisfied. So after that, you now maximize or minimize Maximize or minimize. Maximize or minimize is when you use your ruler and we refer to this one as set squares. If you use your ruler or set square, you use your ruler and then you slide a set square along that such line where the ruler touches or is parallel to that such line. Then the point which is closer to the such line and is much more feasible, then that point is what we shall refer to as the minimum point, where you will find your minimum expenditure. And if you find the point, one of the point is much more further from the such line, then that point will be our maximum point. And if you use the coordinates of that point and replace it in the equation of the objective function, you will find out that is the maximum amount that contractor can use. You can use the same procedure to calculate any kind of problem you have that needs to be maximized or minimized. And the whole process of what we have done here is what we refer to as linear programming. With that, we have come to the end of linear programming. I believe the topic has been interesting,